Welcome back to Social Data Analysis. Today we're going to learn a bit more about data frames, and I would also introduce you to ggplot2 and dplyr, two packages in the tidyverse that helps you with data visualization and data manipulation. But all that we have done so far in R is to bring you closer to R programming than you probably were before. And I'm going to put two books in the description that's going to help you learn R programming much more in detail. But I really advise you to practice, keep practicing. If you need to go back to some of the videos that we've done, that would be nice. And also look up data sets online that helps you practice R programming. Social data analysis would still provide you with several videos in R programming that would help you get better. But you should practice as often as possible, and you're gonna be an R pro very soon. After these introductory lessons, I'll still be bringing you videos in R programming that can help you get better. But if you haven't subscribed yet, please subscribe, like, and then also send me a comment and let me know what I can do better. I really appreciate that. But for now, let's get into the lessons and learn more about data frames. So ggplot2 and dplyr are not default packages in R. So you would have to manually install them. To install a package into R, you need this function called install.packages, and you put into inverted commas the name of the package that you want to install into R. If you already have ggplot2 on your computer and dplyr on your computer, you don't have to install these packages. But if you do not have them, you would need install.packages to install them on your computer. Install dplyr on my computer as well. Now, after you have your packages installed on your computer, you would have to call them into action. You have to call them into action. So ggplot2 and dplyr are already installed on my computer. I call them into action by using the function library. So this brings ggplot2 and dplyr onto my environment, so I can use for my data visualization, data manipulation that I want. Just in the previous lesson, I want to load my mtcars dataset. Remember, the mtcars dataset was dataset on some car brands and different specifications of the cars. So let's go ahead and use head to have a snapshot of our dataset. As usual, we want to know a bit about our data set. So do that. Okay. So this gives us a snapshot of everything that we have in our data. In our previous lesson, we didn't check for missing values. In our previous lesson, we didn't check for missing value. But it's very, very important to check for missing values, because you want to have an idea of how much missing values are in your data set and what to do with them. Now, when you check for missing values, the output you get is a logical value, whether true or false. So this function here, s.na, is just saying, is there any missing values, or are there any missing values in proper grammar? But it's just asking R to check if there are missing values in my data set. Now, if I run this, I'm going to get a logical value of true or false. Now, the false here shows that there isn't any single missing value in my data set, and that is good. But a lot of data sets are not like this. Mostly there are missing values in your data set, and if you want to know the sum of missing values in your data set, you can use the sum function. Then you call in the same s.na function inside the sum function to have an idea of the number of missing values in your data set. Because sometimes some missing values are irrelevant if they are very small, looking at the size of your data. So you might not want to bother about it, and the only way you know is to do a sum of your missing values. And this is how we do that. Now, we don't have any missing values. That is good. But assuming we had missing values, we would have to do something about how to treat missing values. Depends on your research question. It depends on the project that you are doing or the task that has been given to you as a data analyst, and you have to understand your data, understand your question before you know how to treat your missing values, right? Now, in this particular project, I want to treat my missing values, if any, with the average of a particular column. So assuming I had missing values in my mtcars data set, and then the missing values were in the mpg column, I could personally decide to average mpg column and use the average to replace any missing values. And probably my intuition will be, well, I don't know what was supposed to be there, but the average of everything might work for me. Now, assuming there were missing values in my mpg column and I wanted to treat those missing values, I would need a code like this. Now let's break down this code. I created an object here for which I'm going to assign this function. Now the object I created is mtcars $mpg. Now what the mtcars $mpg does, as we've learned, is that it brings out the mpg column from the mtcars dataset. Just that. So bring out the mpg column from the mtcars dataset. Now remember we learned about indexing. Indexing is selecting some part of your data and doing something with it, right? Now to index, we need the squared bracket. So we bring our squared bracket and say, if we have any missing values in our data set, inside mpg, create an object, right? So if there is any missing values, remember that inside your squared bracket, anything you put there is either subsetting some part of your data set or replacing some values in your data set. Now we are saying that if there is anything that is a missing values in the mpg column, create an object. So we just created an object. Now what do we want to replace these missing values that we've created as an object? We want to replace it with the mean of our mpg column. In other words, I want to replace all missing values in my mpg column with the average of that same column. Now because I'm interested in the average of the column, I don't want any missing value inside the average calculation. So I introduce a new argument inside my mean function that removes any missing value from the calculation. So na.rm is true tells R that if there are any missing values, which is usually denoted by na, remove it, which is a shortcut rm, equals true. It means any missing value in my data set, exclude it from the calculation of a mean, so that if I get my mean, I can assign it to all missing values in the same column. Now this is very intuitive because I get to replace some value that I don't know by the average, right? And if I thought that having a missing values would really bother me, and then I'm gonna have sleepless nights, this is the way that I would want. Well, we didn't have any missing values from the beginning, but this was to help you know how to treat missing values if you came across such in the future. Let's move away from trying to find out things that have gone wrong with our data to trying to understand patterns, right? Let's do something about correlation. So if you don't know what correlation is just a statistical measure that describes the extent to which two variables vary, or the extent to which two variables change together. So we want to find out, are two variables related in a way that a change in one affects the other? In research, one thing that we say is correlation does not mean causation, and that is very true. But in this case, we want to see if the pattern exists. I'm interested in if there's some correlation between the cylinder column, right, and the horsepower column. Now, why am I interested in a correlation between cylinder and horsepower? I want to find out if the size of the cylinder in a particular car affects or has some relationship with the car's horsepower. Do higher cylinder values in cars correlate with higher horsepower? So I'm going to go ahead and introduce to you the correlation function in R that helps you check this relation. It is just cor, which is COR, a short form of correlation. What I do first is I create an object called cors CYLHP, right, which is going to be my variable for the value I get. I call the call function. I bring up my cylinder column, I bring out my horsepower column, and I calculate the correlation. Now, anytime you calculate correlation, you expect a value between 0 to 1. The more closer your value is to 1, the higher the correlation between these two variables. So if we check our object, we see that 0.83 is the correlation between cylinder and horsepower. It looks like there's a pretty good correlation between these two variables. You can go ahead and have this printed out in some stylish fashion. Maybe you want to show this to your boss, and then you say, okay, print the correlation value with these words. So you can have R print correlation between cylinder and HP and gives you the value in some sort of a fancy way. So let's move to ggplot2 a bit. We found that the correlation between cylinder and horsepower is quite high, but we want to draw a scatter plot. I'm going to break down this code for you. Later on, I'll bring a full lesson on ggplot2 that helps you understand how to do data visualizations. But this code is just a very simple code that gives you an idea of how ggplot2 works. I want to use ggplot2 to draw a scatter plot for cylinder and horsepower to check the correlation from a pictorial. To do this, I call a function called ggplot. Then I load in as my first argument the mtcars dataset. The mtcars dataset is my first argument. Now I introduce some aesthetics. These aesthetics are sort of part of your graph that the x-axis and the y-axis, how do you want to plot them? So I want to plot on my x-axis the cylinder column. I want to plot on my y-axis the HP column. Remember, I've already loaded my data set, and in ggplot2 I don't have to bring empty cars with a dollar sign. So I can just type in the name of the column. I assign it to the x-axis or the y-axis. So the first part of our scatter plot is ready, but we want to introduce more things. So in ggplot, we get to bring in a plus sign that helps us add more things to our graph. I want to introduce color to my graph, and to do that I use a function called geonPoint. Now geonPoint is sort of the scatter point. I'm interested in a scatter plot, so the point on the scatter plot is what I'm interested in making it dark blue, and that I'm gonna do with geonPoint. Now I bring in my plus sign. I want to label my graph. I want to title my graph scatter plot of cylinder and horsepower. That I use the function labs, and then I introduce an argument for labeling my x-axis and labeling my y-axis. This is all I have to do to draw my scatter. So these are some of the basic things that you can do with ggplot2, and we're going to talk more about this later on. But let's run this code and see how the scatter plot looks like. Wow. Okay, so you need to see this. You need to see a bigger graph. Okay, so this is how it looks. This looks quite not intuitive, right? But I know the problem. The problem is that we are dealing with discrete values. Anytime you plot a discrete value with a continuous value, or you plot two discrete values, this is how your graph might look like. Remember, in the cylinder column, it was made up of discrete values, just 4, 6, and 8. And if you have a column like this and you are plotting it against a continuous variable, it is likely that your graph will not look intuitive. So just so you know, we didn't really see much from this, but it was good that you see how to plot a scatter plot, and it was also good that you know that discrete values do not give you good scatter plots. But our aim has been achieved. Let's go on to doing something else. Let's bring in the dplyr. Let's look at our mtcars dataset, and let's look at the column cylinder. In this cylinder column, which is the second column inside our dataset, we see that there are three values that the column assumes. It has 6, it has 4, and it has 8. Now, as a data analyst, you might be interested in the average of a particular column based on the values of another column. For example, you might be interested in the average of the MPG column if the number of cylinders in the car are 6 or the number of cylinders in the car are 8. So you want to find out the different averages for the MPG column based on the different values that cylinder assumes. And this is sort of some advanced calculations that you can do if you have dplyr. So at this point, let's bring in our dplyr package and then do this calculation. Now I'm going to put in here this chunk of code and break it down for you. Let's roll from behind, right? Behind the lines and move forward. Now I'm interested in finding out the mean of my MPG column, right? I'm interested in finding out the mean of my MPG column. Now, I just don't want to find the mean of the MPG column. I want to find the mean of the MPG column depending on the values in the cylinder column. So I want to group the cylinder column by those that have the cars that have 4 cylinders, 6 cylinders, and 8 cylinders. And then based on that, I'm going to calculate the mean MPG of each of these cylinders. So I create an object as usual that I'm interested in, and this can be any name that you want. And then I load in my data set. I assign to it, the first thing I assign to it is my data set. Now I bring in a pipe, right? In R, we call this a pipe. Now what the pipe does is, just in normal life, right? A pipe connects some outlets to another. So what a pipe does in dplyr, is that it connects one part of your code to another part of your code. So we're going to use this pipe to connect our mtcars dataset to a new function. Now the new function that we have here, we're going to start on a new line, but look at how I indent my code to make sure that it's not on the same line as the ggplot. Now the next function that I have connected to my data set is a group by function. Now what a group by function will do is that it is going to group separately all the values in the cylinder column. So the cars with 4 cylinders are going to be grouped separately, cars with 6 cylinders separately, and cars with 8 cylinders separately. So after group by cylinder and our pipe, we bring in a summarize function. Now remember, within the summarize function, we have the mean function that calculates the average of the MPG. What the whole line of code in line 43 is doing is that for each group defined by the unique values of cylinder, the line of code will calculate the mean of the MPG column and create a new variable called average MPG to store these mean values. So we want to create a new variable inside our data set that would have the values of average MPGs depending on the number of cylinders. And then that is what line 43 will do for us. Let's run this code and look at how it works. Now, if I run these functions that I have here and I call in let's call in our data set, let's have a snapshot of our data set again, you realize that we can check to see what really happened with our data set. Remember, we created a new object called ggdplyr for which we assigned everything to it. Now let's call ggdplyr because ggdplyr is the new data set that has what we really want in terms of the mean MPGs grouped by the number of cylinder. Now if we do that, we realize that a new column has been introduced into our data set, which is avg MPG. And what the column does is that it gives you the average mile per gallon for all the different types of cylinders. Let us pause here to interpret these results. What this simply means is that we have the average mile per gallon for cars that has 4 cylinders, 6 cylinders, 8 cylinders. This is very intuitive. This is very good because then you get to know how different cars perform with the number of cylinders that they have in there. This is very good for you to know. This lesson is to give you an introduction to ggplot2 and dplyr and some of the advanced stuff that it can do, as well as introduce you to some other data manipulation techniques. This is the end of an introduction to data frames. I hope you enjoyed the video. If you haven't subscribed yet, please do subscribe. In our next lesson, I'm going to talk about how to write nice code, and we'll probably be wrapping up with introductions to RProgramming. But please like and subscribe and also leave a comment. I really appreciate it. And I'll see you in the next lesson.